So I'm really glad actually that Ellen in her presentation also spoke to Green Labs and about the behavior and really working with researchers, undergrad and grad students and PIs, in addition to, the very talented lab managers. Because our next speakers, who I'm delighted to have on our team at the Office for Sustainability, and our funding model, are embedded resources actually working within the Faculty of Arts and Sciences, which is our largest college, which includes Harvard College, FAS Graduate School, and the Science and Engineering School as well. So I'll just introduce them, and they are going to talk about Harvard's Green Labs program. FAS has had a formal Green Labs program working with Occupant since 2008, which is the same year our office started. But in addition to that, I would say that, and I'm looking at the folks in the room like Don Gillis, Longwood, as well as FAS and Cs, have had folks focused certainly with working with folks before that. But this has been, a formal program. So Quentin Gilly is a senior sustainability coordinator in our office. And interestingly enough, he was actually a lab manager and automation specialist over at the Harvard Medical School before joining our team. And he is 100% focused in working in the labs with occupants. And then Anthony Michetti, who is also a sustainability coordinator on our team, works within FAS with labs, but also more broadly with other sectors. There are 9 sectors within FAS offices and other spaces. So they are heavily focused on reducing energy and working in labs. So with that, I will turn it over to them.
Thank you all for coming. So today I want to talk about some of our occupant engagement programs that we do with the labs. They're data-driven, looking at trend reports from sub-metering, from fume hoods, and that sort of thing. Just to give you a bit of a background, at Harvard we have a holistic sustainability plan that looks at the spectrum of what sustainability really means. So not only looking at energy and emissions, but also culture and learning and health and well-being. Our current goal is to reduce our greenhouse gas emissions by 30% by the end of this year, including growth from our 2006 baseline. And tackling the energy use from our labs is a big component of that. Just to point out a few areas where we are focusing currently on reducing our emissions. Number one is fume hoods. We have a mix of constant air volume and variable air volume fume hoods. So getting more variable air volume fume hoods in our labs so that we can shut the sash and save energy. And we drive this with competitions, which I'll also speak on today. We also focus on freezers, very energy intensive component of our plug load profile, and as well as equipment and lighting. So running competitions with our lighting and as well as plug loads. We are looking at pulling all of this together and doing a incentive program so that we can actually give labs a financial incentive for cutting back on their energy use. And we're working with a number of people across campus at the law school on that project. So why target fume hoods? At Harvard, we have nearly 1,000 chemical fume hoods on campus, mixture of VAV and CAV hoods. Operational costs could be as much as $3,000 per year, if not a lot more. Some of these spaces, as was discussed earlier, we have high density of fume hoods, and in these spaces, it can really drive the HVAC system and the air change rates. An example of this can be seen on these graphs here. So at the top here, you have a chemistry lab, and these are air change rates plotted over time. And you're looking at 15 to 16 air changes per hour, primarily because there's so many fume hoods in such a dense space. and then you compare that to a biology lab area, and you have much lower air change rates, primarily because there's less fume hoods. But in these areas where this thing is tricky. In the areas where we do have high density of fume hoods and we think we can save a lot of energy, we run our Shut the Sash competition. So this is a friendly competition between individual labs, and currently we're saving as much as $250,000 per year and 350 metric tons of carbon dioxide emissions. Currently we have 33 labs involved in the competition. It was originally started in our Department of Chemistry and Chemical Biology, where we have 19 labs, but we recently expanded this to a number of additional labs where we thought we could save a lot more energy. So starting out with this, one of the main ways to get researchers to really understand what we're looking for as far as behavior, we installed these LCD screens that report in real time the CFMs coming out of all the hoods for an individual group. So for example, the CFM monitor right here, there's about 20 or so hoods in this space. And as people in the lab open and close their sashes, this number will change immediately. And above that, we have these displays that explain exactly why that's important. So they can see their minimum and maximum numbers of what that display could potentially read, depending if all the sashes are open or closed. And then we explain the importance of why shutting the sash will save energy and emissions. And next to that, we display their previous month's CFM average, as well as their goal. And if they achieve their goal, they get in the running for a celebration pizza party, something like that. But so the LCD screens that we installed, we originally installed 19 of them, and they weren't really cheap. They were about $5,000 each. But our ongoing costs are very low compared to what we're actually saving. We're looking at about 10 hours of my time per month to run a competition and do the analysis, and only $4,200 per year to actually pay for all the celebrations and that sort of thing. In addition to saving a lot of money and emissions, one of the things that the researchers and lab managers constantly tell us, thank you for doing this. It really gives the researchers an opportunity to socialize and have a common goal. And it also creates a safer lab environment by keeping the sashes shut. So it's a win-win for everyone. So I mentioned we recently expanded the competition to a number of new labs, but before I decided to move forward with that, I really wanted to look at how our current Shut the Sash program was functioning, and was it effective at actually reducing our energy costs. So since the competition had been running for about 10 years with very little change, so has the researcher engagement also changed over time. So we collected data over a number of months with different fume hoods, and we looked at 3 different criteria. So we have our Shut the Sash fume hoods in our chemistry department, and then we also have another department with automatic sash closers. So comparing automation to engagement. And then we have a number of other spaces where we have neither automation or engagement, and looking at those buildings as well. So the graph here at the bottom shows the density of fume hoods by space. Here in the green, these are individual labs within the chemistry department, and these are full building counts in these peach and blue over here on the corner. So basically illustrating the high density of fume hoods in that small building complex. So how do you evaluate good behavior versus bad behavior with a fume hood sash? So basically we wanted to be pretty conservative, so saying that any sash opening under 5 hours is probably good behavior. Depending on the research, they maybe could have shut the sash during that time, but we'll consider that good behavior. And then as you increase that time period to 12 hours, 24 hours, then that's increasingly worse behavior with sash management. So we got individual trends from all the fume hoods in these different buildings, and we counted the number of openings per criteria to see the difference in behavior. And then looking at all the buildings down here, so these graphs basically show the mean hour opening times. So comparing, this is the building where we have the automatic sash closer. So this green and gray here indicate 5 hour or less sash openings per the mean. Same here with the chemistry where we do our shut the sash competition. Also, pretty good behavior, looking at mean opening time at around an hour, 1.4 hours. But you compare that to these other buildings where we don't have either shut the sash or automation, the opening times are much higher. You have a much higher count of fume hoods that aren't being managed as well as they could be. So this basically explained that these fume hoods are likely costing us a lot more to operate, and we're contributing to greenhouse gas emissions. And looking at operational costs per fume hood, you look at the CFM per year, how much does that cost? And you compare automation to the shut the sash competition, and the cost of operation is about the same. And it's notably that the shut the sash is in chemistry, where it's much more fume hood intensive type of research, whereas this other building here is biology, less fume hood needed for their daily processes on average. So with this data, we decided to start a new shut the sash competition and see if it could really be effective at keeping the sashes shut. We started that in September, and each month there's more and more labs that are doing much better with their fume hood management. And one other note, during the survey, I met with the building manager and a number of researchers that were in the building that had the automatic sash closers, and there was actually a lot of complaints about the automatic sash closers. People said that they were making noises and they were interfering with their work. There was actually several instances where the researchers were disabling the sash closers. That's why we decided to go with the shut the sash competition instead of the automation. In addition to fume hood management, we also look at our freezers as one of our main plug load energy users. We do preventative maintenance programs at FAS, Faculty of Arts and Sciences, and this helps with freezer performance over time, reduces the number of breakdowns, increases longevity of freezers. We also do an incentive program to try to bring in more energy efficient freezers into our buildings. And we do that by providing a financial incentive to the labs. So the idea is that the energy efficient freezers are going to cost a bit more. So since the labs don't pay their energy bills, we try to give them an additional incentive to bring that cost about to what it would be compared to a different retail freezer. Here at the bottom, you see energy use over time. This is in the red here is a standard Revco freezer compared to the blue here with the Sterling. So as you can see, energy consumption is much lower. And a lot of times it's actually about half the energy consumption with more of these high-performing models. In addition to preventative maintenance, we also do equipment monitoring. We partnered with a company, TetraScience, who actually came out of the same labs where we're doing our Shut the Sash competitions. And they've developed Wi-Fi connected devices that will actually let the users remotely monitor their equipment settings. So they can look at their incubators, their freezer temperatures, and if those temperatures get out of the safe zone, they get text message, email notifications. They also allow people to remotely turn off equipment. So things like hot plates, heat blocks, that sort of thing. They could turn those off at night if they forget, whether in the lab or they want to let an experiment run for X number of hours. They can turn it off remotely. So this is just a number of different programs we're working on right now. I want to turn it over to Anthony Michetti, who's going to talk a little bit more about our occupant engagement programs.
Thank you, Quentin. So, why occupant engagement versus simply implementing energy conservation measures on campus or implementing technological solutions that can reduce energy usage in spaces without the occupants really having to think about it when they go into the space that they're going to be spending a majority of their time? Going back to the university's sustainability plan that Quentin mentioned, we have our greenhouse gas emissions reduction goal, we have a waste reduction goal, we have a water reduction goal. One of the categories that the holistic plan focuses on is also culture and learning. So we want to be able to engage with our stakeholders, educate students, faculty, researchers, be able to give them the ability to make the best decisions to physically reduce energy, help us meet these goals, and help us build a more sustainable campus community. It's also been proven to work in the past, just looking at a couple occupant engagement examples that have been able to create sustained behavior change that you may be familiar with, the Prius effect and O-Power. I don't know if any of you in the room drive Priuses or have rented one or driven in one before, but when you're physically sitting there driving, you can actually see your fuel efficiency in real time, adjusting your behavior depending on how aggressive you're driving, and see how that behavior actually affects the fuel efficiency of the vehicle. O-Power is a company that works with utilities, and they develop various customer engagement platforms. One of the more successful projects that they've done that we've been able to learn from was actually on your utility bill, being able to see how much energy, electricity your neighbors are using, so that you can see how you're performing in relation to the person across the street, whether or not you're leaving all your lights on, leaving all your TVs on, and using a lot more electricity, or if you're one of the people in the neighborhood who is doing more energy efficiency measures and actually reducing the amount of electricity that you're using. So how can we engage with our stakeholders, specifically looking at researchers? We run a lot of different campaigns, as Quentin discussed. We're finding that having data to be able to support and drive these campaigns has been very beneficial. It allows us to go and create baselines, actually measure the effectiveness of the programs that we're running to see how they're performing. One example of this is implementing sub-metering. The ability to actually measure and monitor the electricity usage of, say, separating out plug load associated with certain equipment, or looking at lighting fixtures. Researchers are very competitive. They're all here trying to be the first to do something. They're trying to be the first to solve a problem. They compete with each other within their groups. We see it all the time. They compete with other groups. They compete with other universities. So being able to engage them definitely is a good opportunity to feed off this trait. And of course, the reward and recognition. Everybody seems to love free alcohol, free food. That definitely gets them on board. I know I have my drink tickets for the networking session after this. That's actually how they got Quentin and I to speak today. And then we offer other prizes as well. We've worked with facilities teams. One team actually built a huge trophy for one of the campaigns that we've run, so it's been pretty awesome. Get everyone on board, get everyone excited. It definitely increases participation in the different programs that we're looking at. This is very touchy. So looking at one of our successes, to give you a specific example of an occupant engagement campaign that we've run on campus, almost a year ago, last April, we were able to run a lighting competition between 3 groups in our chemistry department. Each of the groups occupies a newly renovated space, and within each space during the renovation, we were able to implement sub-metering, so I could actually get kilowatt readouts for equipment plug load and lighting fixtures separately. With those, I was able to create a baseline and collect data during a month without telling any of the groups or anyone that anything was going on, making sure they weren't going to adjust their behavior before time. And then during the month of April, I actually ran a 3-week competition looking at a percentage change, the weekly kilowatt hours from the baseline data. The winning group, amazingly, actually was able to reduce from their baseline almost 74%. The other groups were significant as well, 25% reduction and a 15% reduction. And overall, this is about 60,000 kilowatt hours we're looking at annually, so around $7,000 for the university And again, this was just 3 groups within one department. The chemistry department has about 30 groups. So we're looking within that one department. If we were to roll this out and expand it, there is an opportunity for 10 times those savings. And again, we have many other departments spread out throughout the university. Just looking at some of the graphs that we were able to generate and share with the groups from the sub-meter data that was collected. This here is actually the winning group, and you can see this is their worst week during the month baseline that I collected, and then their best week during the competition that we ran over 3 weeks. You can see at their highest usage during the competition, they're barely getting to where their lowest usage was during the baseline. And they're doing a much better job of actually turning off all the lighting fixtures overnight when nobody's utilizing the space, but they were also turning off a lot of fixtures during the day, maybe in areas that were overlit or didn't need to be lit. And just quickly looking at the 2 other groups, how they performed, not quite as well as the first group. The first group was able to implement some exciting and interesting different ideas to do what they did. But you can see that overnight, people are definitely turning off lighting fixtures as they leave and nobody's in the space. And during the day, they are turning on fewer fixtures, perhaps in areas where they aren't needed, versus just going in, turning all the lights on, leaving them on. Now, sustaining this behavior. So we did this competition. It was just 3 weeks. The researchers are busy. They're thinking about lots of other things. It can be hard just to get a minute of their time. But having the actual data continuously collected from the sub-metering, we're able to share that, generate things that we can share with them, keep it on their mind. We actually ran a couple week-long surprise spot check competitions, so they didn't know when those were going to happen. They knew that it was going to happen, just not when. So being able to have all that and do that definitely kept it on their mind. And you can see, so during the 3-week competition, the combined 3 groups, we witnessed a reduction of about 38%. And again, it's been almost a year, so I have almost a year's worth of data since then, and we're looking at just a 2% change since then. So they've actually been able to sustain this lighting behavior. Just looking at a couple of the groups individually and how they've been sustaining their behavior since the competition. So this graph here shows their baseline month that I collected before letting them know about the competition. Then it shows their average weekly kilowatt hour usage during the competition. And this is each week since the competition. Again, almost a year's worth of data. This was the group that won. Their behavior probably realistically wasn't sustainable, but you can see that they haven't approached the baseline at all, and they have actually done as well or even better a couple weeks here and there as they did during the competition. The other 2 groups, you can see that they're actually performing a lot better many of the weeks than they did during the competition. And again, not approaching the baseline at all and still witnessing some pretty good improvements from that baseline. Now, looking at this specifically, some of the opportunities that we see moving forward and some of the issues and barriers that we've seen doing the lighting competition and some of what Quentin discussed. A lot of times we see that sub-metering just isn't in the project budget, or it's the first thing value engineered out. A lot of times people don't know what product to choose, or if they do actually incorporate sub-metering into the project, it might be installed improperly. It may not be connected. It's there, but we can't actually get data from it, or no one knows how to use it. So our Green Building Services department here at Harvard is actually working on creating a sub-metering guideline, so we see that as something that would be useful to share with project teams, project managers, to really get them on board with implementing sub-metering in new renovation projects or new construction. It'd be great if there was an incentive from the utility to help with these costs so that it wasn't the first thing cut from the project budget. We also see it as an opportunity to not only measure the success of the campaigns that Quentin and I are running, but looking at measurement and verification to be able to look at recently implemented energy conservation measures to actually decipher how well they're working and whether or not they're worth implementing in other areas. We see this as a good opportunity to measure those. Live displays and dashboards. Right now, the only live display that we have where you can actually physically change your behavior, go out and see the effects that it's having, are the Shut the Sash CFM LED readouts. I know that Ellen mentioned that Cornell has their dashboard. We'd love to see something like that either displayed outside the labs with the LED readouts or in a central location within the building, just to be able to compare the different groups, compare to other buildings, compare to other universities. It would just be great to actually engage the occupants and show them the effects that their behaviors are having in real time. And if you're interested, nope, I exited out. But if you're interested in learning more, we do our best to share tons of resources, case studies on all the programs, campaigns that we're running. We look at the university as a living lab. We're trying to generate replicable outcomes that can be shared and utilized across all different sectors. Quentin just published a white paper on the Shut the Sash, so that's up there now. Definitely go there and check that out. I'm going to throw it back to Quentin quickly, and he's going to introduce our next speaker. Thank you.